So today also we now to look at another topic called theory logarithm. Theory logarithm is very important topic also in mathematics as it is related with an indices. They are related to each other, or we can say vice versa of an indices. So indices, if you can recall, index notation of, let's say, 16. The index notation of 16 in an indices is 2 to the power of 4. Where we can call 16 as a number, while 2 we can call it as a base, while 4 we can call it as a power in an indices. So now when you turn to a logarithm, as we have 16 equals to 2 to the power of 4. So here we can say logarithm of 16 of this number and base of this number, which is 2, so is going to be 4. Like if we take another example, when we said 81, what is the index notation of 81 is 3 to the power of 4. Because 3 times 3 times 3 times 3 is going to be also 81. So when we turn it to what? Logarithm, we can say logarithm of 81 to base of 3 is equals to also 4. This means that logarithm and indices, they are related to each other. This is what we call index form. That is 81 is equals to 3 to the power of 4, and this is what we call logarithm form. Logarithm form. This is the relationship between indices and a logarithm. And also, if you now look at an index notation, when we state 1, if 1 is equals to 10 to the power of 0, yes, we agree with this according to an indices. That is, 1 is any number raised to the power of 0 is 1. So if 1 is equals to 10 to the power of 0, so here we can now say logarithm of 1 base 10 is going to be 0. And also if we take 10, 10 is the same thing as 10 to the power of 1. So here we can also write logarithm of 10 base 10 is equals to 1. And also if we take 100, we say it is 10 to the power of 2. That is 10 times 10 is 100. So we can say logarithm of 100 to base 10 is going to be 2. And also when we take 1000 is 10 to the power of 3. So we can say logarithm of 1000 base 10 is going to be 3. So logarithm and indices, they are related to each other. And also, mind you, we have what we call as common logarithm. A logarithm that has log, when we say base 10. When a logarithm has base 10, is what we call as common logarithm. Common log, when it is in base 10. But all the other bases of logarithm is not a common logarithm. It is only when a logarithm is in base 10 we can call it as common logarithm. And at times the base is omitted. That is, we can write log like this, is mean base 10. So no need of us to write the base when it is base 10 because it is a common logarithm. We can write 10 and if we like we can just omit the base. And this is a relationship between indices and a logarithm. Then we'll now to see what are the problems under logarithm. So let's look at an example under logarithm. They say evaluate the following without using table or calculator. You're not going to use table and also you're not going to take a solution from the calculator. That is, A, we have log 81 base 3. What is going to be log 81 base 3? Here we have log 0.0625 base 4. Here we have log 32 base 8. And D we have log 128 base 2 root 2. So normally when we talk about theory logarithm, we are talking about logarithm that is a common logarithm and the logarithm that is not a common logarithm. But when you go back to the other logarithm of a number, it's only based on the common logarithm. That is when a logarithm is in base 10. Take a solution of this problem. We say evaluate the following without using table or calculator. So without taking a solution from calculator or from table, you now to simplify 5, that is to evaluate these examples. Log 81 verse 3, log 0.625 verse 4, log 32 verse 8, and log root 128 verse 2 root 2. So normally when we talk about theory logarithm, we are talking about a logarithm that is in any base, that is either in common logarithm or not a common logarithm. But in the other logarithm of a number is talking about logarithm that is in base 10. That is a common logarithm. That is why you see all this one, we have verse 3, we have verse 4, we have verse 8, and we have 2 root 2 as a base. So we have to know how to use a theory logarithm and now find out these problems. Then here we now to start with solution of A is logarithm of 81 verse 3. So look, what is going to be logarithm of 81 verse 3? Let's name it as x. That is to be value of x. So now this is a logarithm form, so we have to convert it to an index form for us to get the value of x here. So here we say 3 is a base, then x is a power, if we can recall. Then here we say 81 is a number. 3 is the base, x is the power, then this is the number. So 3 to the power of x equals to 81. So here we say 3 to the power of x equals to 81. We have to express the same base with these. That is, we say 3 to the power of 4. So now equate the bases. This is 3, this is 3. So now the value of x is equals to 4. So now we can say logarithm of 81 verse 3 is equals to 4. And that is the answer. B, we have log 0.0625 then verse 4. So now we don't know what's going to be logarithm of 0.0625 verse 4. Let's name it to be y. So now as usual, this is in logarithm form, we have to convert it to an index form. That is, we say 4 as the base, then y is going to be the power. This is equals to 0.0625. So now here we have 4 to the power of y is equals to this 0.0625 in an indices. You have to convert it to be in form of a fraction. That is, we have to say it 625 all over 123. Then we say it all over 10,000. So now here we have 4 to the power of y equals to 625 divided by 10,000. So here we can say it 4y equals to 625 into 625 goes 1 times, then into 10,000 is now going to be 16 times. So here we have 1 all over 16. So now as we have 1 all over 16 here, we can now say 4 to the power of y is equals to 1 all over 4 squared. So now here we can say 4y is equals to, this is a negative index, that is, we say 4 to the power of minus 2. That is 1 all over 4 squared is the same thing as 4 to the power of minus 2. So since here is 4, here is 4, we now equate the verses. So y is equals to minus 2. So this to show that logarithm of 0.0625 base 4 is equals to minus 2. And that is the answer. So now we have the C, logarithm of 32 base 8. So logarithm of 32 base 8, we don't know. And so we now let it to be, let's say also to be x. So 8 is the base, then we take the power of x. This is equals to 32. So now 8 to the power of x equals to 32. So here we can now make this and this to be of the same basis. That is, here we can now say 2 to the power of 3. 2 to the power of 3 is 8. So here we have x, 2 to the power of 3x. This is equals to 32. We can say 2 to the power of 5. Because 2 times 2 times 2 times 2 times 2 up to 5 times is going to give us 32. So they have equal bases, then we equate the bases, then these go with this. So here Here we have 3x equals to 5. So we need to know x. We now say divide both sides by the coefficient of x, which is equals to 3. So 3 cancel 3. So now x is equals to 5 all over 3. So also here we can state log 32 verse 8 is equals to 5 all over 3, and that is the answer. Let's look at the other example, that's D. We have log root 128 verse 2 root 2. This is another problem under a logarithm. Logarithm of root 128 verse 2 root 2. Let's name it as y. So now here we say 2 root 2 is the base, 2 root 2 is the base, then y is the power. This is equals to root 128. So now when we have this, we can now say square to both sides. Square to both sides. That is, here we can say 2 root 2. Then here we have 2y. Because we have a y before, then we now have a power of 2. Then equals to 128. Because the power will now go with the root. So now here we have 2 root 2 to the power of 2y into equals to 128. So now here we can say this is a power, it will be 2 to the power of 2. Then also we say times this is root 2 to the power of 2. Then all to the power of y. Because this square is belong to these two and this square is now belong to these two. So here it's equals to 128. So here we can say 2 to the power of 2, then times. Here this 2 will go with this root. So remainder of what? 2 to the power of 1. Then we now to say to the power of y equals to 128. So according to the first law of indices, here is 2, here is 2. They have the same base. So here we say 2 to the power of 2 plus 1. Then all to the power of y equals to 128. So now 2 to the power of 3 times y, we say 3y equals to 128. And here we say 2 to the power of 3y is equals to 2 to the power of 7. Because 2 to the power of 7 is 128. So we now to equate the verses. So here we have 3y is equals to 7. So as we have 3y equals to 7, so we can say y is equals to 7 all over 3. When you divide both sides by the coefficient of y, which is equals to 3. 3 go with 3. So y alone is equals to 7 all over 3. So here we can find logarithm of root 128, then base 2 root 2 is equals to 7 all over 3, and that is the answer. Now we have to look at the rules under logarithm. That is, we can call it as law of logarithm. Now here we have log mn base a. That is m and n, it is a multiplication between, and they have base of a. So this is equals to log of m with base of a plus log of n with base of a. This is the first law of logarithm. That is, when here it is a multiplication, then here you have to separate and give them an addition. Then here we have a division. When logarithm of n over n, the same base of a. So we are now going to take logarithm of m base a minus, because here is a division. Then we say minus logarithm of n base a. And also we have what we call as a power log. Then logarithm of m to the power of n base a. This power is going to go back to the log. That's why here we have n log m base a. This is the third log. Then the fourth log, logarithm of a base a is equals to 1, which means that logarithm of a number of the same base is equals to 1. Logarithm of 10 base 10 is 1, logarithm of 2 base 2 is 1, logarithm of 3 base 3 is 1. So that's why here we say logarithm of a base a is equals to 1. So here we have the fifth law, that's logarithm of 1 base a. Logarithm of 1 to any base is going to be 0. Logarithm of 1 to any base is 0. Then we have number 6. When we have logarithm of 1 over a, that is the denominator to be the same with base, is going to be minus 1. And here we have logarithm of 1 over different number and base a is going to be minus log of this number base a. These are the 7 laws of logarithm. Now we have an example of these. Simplify each of the following as a single logarithm in its simplest form. So now here we have a, we have logarithm of 3 plus logarithm of 8. And this is what I have been telling you. You see the base is omitted. So which means that the base is what? Is base 10. So 3 minus log 25 base what? Base 10, but it's omitted. Then also here we have 3 all over 4 log 16 base what? Base 10, and also the base is omitted. So now here we now to look at solution. Log 3 plus log 8. This is base 10, this is base 10. They have the same base. So here we can say it logarithm of 3 times 8. That is from the first law. When it's multiplication, you now turn it to addition. When it's here is addition, then you have to multiply the 2 logs. So here we have log 3 times 8, we have 24. So here we say log 24. This is in its simplest form. Then we have the 3 minus log 25. 3 minus log 25. Mark you, this 3 is the same thing as to say it logarithm of 1000, because this base is base 10. So you have to refer this base also as base 10. When it is base 10, what is the number that is going to give us 3? So logarithm of 1000 base 10 is 3. So here we say minus log 25. So since here is minus, that is from the second law, so we can just take one of the verses that we say log 1000 divided by 25. Which here we can say log 40, and that is the answer. We now to look at the C, which is 3 all over 4 log 16. So this is a power. Then we take the power to the front of the log. That is here we can say log 16 to the power of 3 all over 4. Log 16 to the power of 3 all over 4. I mark you, if you can recall, we can say logarithm, this power of 3 over 4 is the same thing as we can say first root of 16 then to the power of 3. Log first root of 16 is 2, because 2 times 2 times 2 up to 4 times it will give us 16. So here we say 2 to the power of 3. So here lastly we can say log 8. And that is the answer. We have what we call a substitution in logarithm. When we say substitution in logarithm, they are to give us a number that is from a common logarithm that all are in base 10. So when you come to a point, that is a place that you're going to substitute. That's wherever you see log 2, you're not to substitute with 0.3010. Wherever you see log 3, you're not to substitute with 0.4771. Wherever you see log 7, you are now to substitute with 0.8451. This is how to make a substitution along the line when you are solving a problem under a logarithm. So here we have an example. We said A, we have log 108 base 10. B, we have logarithm of one number 1 over 3 base 10. Then here we have logarithm of 0.49. Here we have base 10. So here we can now take here and say solution of A. That is log 108 base 10. Log 108 base 10 is the same thing as to say 9 times 12. 9 times 12, it will give us 108. Or if we like, we can say 27 times 4 is also 128. So any one that we take, it will satisfy the equation. So here we can now take logarithm of 9 times 12. 9 times 12 is 108 base 10. So now here it is a multiplication. As we all know, we have to separate what is here as logarithm. We say log 9 plus log 12. And Here is log 9, here is log 12, but here we don't have log 9 or what, log 12. So we have to go for that. That is, here we can say log 3 squared. Log 3 squared is 9. Then here we can say plus. This is log 12. That is, we can say log 4 times 3. Also, we have to break it up. Then here we have, this is the power of 2. We take it back to the log. We say 2 log 3. That is the power. We now to bring it back to the log. Then we say log 3. Then here we have plus. This is, we can say it log 2 to the power of 2 because it's 4. Plus, because here is multiplication, then we say plus log 3. Then all these, here we have 2 log 3 plus 2 log, log 2 power of 2, then plus log 3. So here we can say 2 log 3 plus, we take 2 back to the log, that is 2, then we say log 2, then plus log 3. So here we have 2 log 3 plus 2 log 2 plus log 3. So here we come to say 2 times. We already have log 3. And log 3 we know that is 0.4771. 0.4771. That is nothing. Then here we say plus. We have plus here, that is 2 log 2. That is, we say 2 times our log 2, which is 0.3010. Then plus log 3 alone. And log 3 alone is 0.4771. So now when we multiply 2 times 0.4771, that is, we can now say it 2 times 0.4771 plus 2 times 0.3010 plus 0.4771. Then here we want to have all and all. When we add together, when we multiply and we add together, we have 2.033. This is the logarithm of 108. That is, we said logarithm of 108 base 10 is going to be 2.030. And if you want to confirm, since it is a common logarithm, you can use a 4-figure table and now confirm logarithm of 108. Right from here, we have 3-digit numbers. And 3-digit numbers, how many characteristics is 2? Then we mark a point. Then we have to take 10 under 8 is going to be 0.330 at the end. So that's why here we have 2.033. That is logarithm of n is this. And also you can use a scientific calculator. When you phrase the number, then you phrase logarithm of 108 is going to be the same. And this is the answer. The V here we have log 1 number 1/3 base 10. And 1 number 1/3 is determined as to say log 3 times 1 is 3 plus 1 as 4 all over 3 base 10. So 4 divided by 3 from the division. Then here we can say logarithm of 4, then minus logarithm of 3. All is base 10. So here we say logarithm of 4 minus logarithm of 3. So we now to break 4. That is, we say logarithm of 2 base 2. That is base 10. Then logarithm of 3 base 10. Then the power, we take it back to the logs. That is, here we say 2 log 2 base 10 minus log 3 base 10. So here we already have log 2 as 0. We say 2 times 0.3010 minus log 3 is 0.4771. So 2 times 0.3010 here is going to be 0.602. Then we say minus 0.4771. Then when we take 0.602 minus 0.4771, we have to have 0.1249. Yes. Here as 0.602 minus 0.4771 is equals to 0.1249, and that is the answer. Take C. log 0.49 base 10. Now we have to say logarithm of 49 all over 100 base 10. 49 divided by 100 is the same as 0.49. So now here also it is a division. So here we can take logarithm of 49 minus logarithm of 100. Logarithm of 49 minus logarithm of 100. So now 49 is the same thing as to say 7 squared. Verse 10 minus logarithm of 100, we can say logarithm of 10 squared. Because 10 squared is 100, 7 squared is 49. So we all take the power back to the logs. So here we can face 2 log 7 verse 10 minus 2 log 10 verse 10. So here we can say 2 times. Our log 7 is 0.8451. The minus 2 times log 10 verse 10. From the other log we know that is 1. So here we can face times 1. So here 2 times this, here we have 0.6902. That is 2 times this is 0.6902. Then we say minus 2. Here all in all we now to have minus 0.3098. So now logarithm of 0.49 is minus 0.3098. If you use table or calculator, it's the same thing. Because 0.49, it has a characteristic of minus 1. That is, it's starting with 0, so we have bar 1. Then we have to take 49 under 0 is going to be 0.3098. So now logarithm of 0.49 is minus 0.3098, and that's the answer. Now we now to look at evaluation in logarithm. That is, at times a logarithm will now come without a base. The base is unknown, or even the logarithm is unknown itself. So here we have, they say solve for x for this equation. That is, A, we have 2 log x base 9 minus 6 log x base 9 equals to 2. Then the second one we have log 4x plus 3 base 10 minus log x base 10 equals to 1. And here we have C, 6 log opening bracket x plus 4 closing bracket is equals to log 64. Then here we have D, log opening bracket x squared plus 4 closing bracket is equals to 2 plus log x minus log 20. Then we have to look at solve for x and y on these. Log x base 6 minus log y base 6 equals to 1. And log x base 6 plus log y base 6 equals to 3. So these are the example under evaluation. So now we start with A, that is solution. A is 2 log x base 9 minus 6 log x base 9 equals to 2. So now since here we have a number at the back of the log as 2, and here we have a number at the back of the log as 6, and here is 2. So we can divide through the equation by 2. That is, here we say by 2, also here by 2, also here by 2. So these 2 will cancel these. So here we have log x base 9 minus 2 into 6, we have 3 log x base 9. So here we can now say equals to, here we have 2 divided by 2, which is equals to 1. So as here we have log x base 9 minus 3 log x base 9 equals to 1. So we now to take, we say log x base 9 minus, this is a power, so we have to take it to the front of the log. That is, we say logarithm of x to the power of 3 base 9 equals to log 9 base 9. Because instead of you to write 1, you have to create something that will not be the same base with this. So what is going to be the same base with this? Since it is 1 and it is base 9, so it has to called log 9 verse 9. Log 9 verse 9 we know is 1. But we want to create something so that it ought to be of the same base in the log, that is verse 9. So here we can take log verse 9, this is x divided by x to the power of 3. Because here is a subtraction, and this is equals to log 9 verse 9. So here we can now dissolve the verses. That is verse 9 and verse 9 are gone. Then here we have x all over x to the power of 3 equals to 9. So this is x all over x to the power of 3 is the same thing as 1 all over x squared equals to 9. Somebody will now say, how comes? Yes, here according to an indices, look at it, this is x to the power of 1 divide x to the power of 3, which is equals to x alone is 1 minus 3, which is equals to x to the power of minus 2. And x to the power of minus 3 is the same thing as 1 all over x squared. So now we now interchange, this is equals to x squared is going to be 1 over 9. Because this and this, when you cross multiply and you now divide, then it's going to be x squared is equals to 1 over 9. So when we have a square on the left hand side, it's now going to be a square root on the other hand. Then we say x alone is equals to square root of 1 all over 9. Then what is the square root of 1? We know is 1. What is the square root of 9? Is 3. So the value of x is 1 over 3, and this is the answer. Solution of v. The v is log 4x plus 3 verse 10 minus log x verse 10 equals to 1. So now if you look at what is here, here is a subtraction. And what we're going to create is what this brought about this 1. Here we can say log verse 10 4x plus 3 minus log x verse 10 is equals to log 10 verse 10. So that they have to be of the same base. So log 10 verse 10 we know is 1. So here is subtraction. So here we can say log 4x plus 3 all over x is equals to log 10 verse 10. So log 4x plus 3 all over x verse 10 is equals to log 10 verse 10. So here we can now to dissolve the bases. The logs go with logs. So here we have 4x plus 3 all over x is equals to 10. So we now to cross multiply. So when we cross multiply, here is going to be 10 times x as 10x. This is equals to 4x plus 3. So now when we have 10x is equals to 4x plus 3, then we collect like terms. So here we have 10x, then this is minus 4x is equals to 3. So 10x minus 4x, we have 6x, which is equals to 3. Then divide both sides by the coefficient of x, which is 6. Then 6. So 6 go with 6. Then x equals to 3 all over 6, which is equals to 1 all over 2. Because 3 into 3, 1, 3 into 6, we have 2. And that is the answer. We have 6 log x plus 4, that is equals to log 64. 6 log x plus 4 equals to log 64. Mind you, this is a power. So we can take it back to this initial form, that is the place. That is x plus 4, then to the power of 6 equals to log 64. So now, on this case, we can take log x plus 4 to the power of 6 is equals to log 2 to the power of 6. Because 2 to the power of 6 is 64. 2 times 2 times 2 times 2 times 2 up to 6 is 64. So now we can go with basis of the logs. So here we have x plus 4 equals to the power of 6 equals to 2 to the power of 6. Then we equate the power. Since the power here is 6 and the power here is 6, 6 go with 6. So here we have x plus 4 is equals to 2. So x alone we can say is equals to 2 here is plus 4. When we take it to the other side, it's going to be 2 minus 2. 2 minus 4. So x is equals to minus 2, and that is the answer. Now to look at the d. The d here we have log x squared plus 4 equals to 2 plus log x, then minus log 20. So in this case, here we can place log x squared plus 4 is equals to 100 under base 10. 2 under base 10 is the same thing as to say log 100. That is 2 plus log x, then minus log 20. So now here we say log x squared plus 4. Since here is addition, then we say this and this, then we say log 100 times x. Then we say minus log 20. So here we say log x squared plus 4 is equals to log 100x, because 100 times x is 100x, then here is minus, so we say divide by it. Divide by what? Divide by 20. So here we say log x squared plus 4 equals to 100x divided by 20, we have 5x. So now, we have log 5x, so we dissolve the loss. Here we have x squared plus 4 equals to 5x. So we can transform here to be this, that is, we say x squared minus 5x plus 4 equals to 0. It's now become a quadratic equation. So how can we solve this? We now have to use a factors of what? The factors we have to factorize. So here we can look for the factors. The factors are, we can take minus 4, minus 4x, and minus 1x, which is x. So we now have to put it in place here. That is, we say x squared minus 4x minus x plus 4 equals to 0. Take a pair. That is, here we have x squared minus 4x, we put it into a bracket, and here we have minus x plus 4, we also put it into a bracket. So we have a common of what? X outside the bracket, remainder of x, then minus 4, then this one we have minus 1 outside the bracket into what? Into x, then into minus 4. So now this one and this one are similar, so we can just take x minus 1, the one that is outside the bracket, we say is equal to 0, and we take the other one, x minus 4 is equals to 0. So when we have x minus 1 is equals to 0, so we can call x is equals to 1, and when x is minus 4, we can say x is equals to 4 and 1, and for any one that you take, it will satisfy the equation, and this is the answer. Now we have to take the last one, that is the e. It says log x base 6 minus log y base 6 equals to 1, and we have log x base 6 plus log y base 6 equals to 3. This is equation 1, this is equation 2. So in this case, we have two ways on how to do this. In the first one, we can just eliminate direct. We can just what? Eliminate. Let's take the two methods. Let's write method 1, or we say step 1. Since this is log x base 6, this is log x base 6, and they have the same coefficient, so we can eliminate log x base 6. So here we have a remainder of minus log y base 6, and here we have plus log y base 6. This is equals to 1, and this is equals to 3. So as we have minus log y base 6 and plus log y base 6. So we can say equation 2 minus equation 1. So here when we say log y minus log y base 6 is going to be 2 log y base 6 is equals to 3 minus 1, which is equals to 2. So here we have 2 log y base 6 equals to 2. So we can take 2 to the power of, here is going to be log y to the power of 2 base 6 equals to 2. So now here we can say it, we can change it to an index form. We say 6 to the power of what? 2 is equals to y squared. Y squared is equal to 6 squared is 36. So when you have a square on the left hand side, it's going to be the square root on the other hand. So y alone is equals to square root of 36. Y is equals to 6. So we get the value of y as 6. So we come and put it in place in any of these two equations. Here we say substitute y in any equation. That is when we take equation 1, when we say log x is 6 minus log y base 6 equals to 1. So now wherever we see y, we now to put 6. So here we can say log x base 6 minus log y. Instead to write y, then we write 6 base 6 equals to 1. So here we say log x base 6 minus the log 6 base 6 is 1 equals to 1. So we take minus 1 to the other side. So here we have log x base 6 equals to 1 plus 1. So here we can say log x base 6 equals to 2. So as we have log x base 6 equals to 2, so we can say 6 to the power of 2 is equals to what? Is equals to x. So now x alone is equals to 36. So the value of y is 6 and the value of x is 36. When you put it in place as something that we call check, it's going to be the same thing. Because here, log x, that is log 36 base 6 is 2. Log 36 base 6 is 2 minus log 6 base 6 is 1. So 2 minus 1, you will have 1. And here we have log 36 base 6. Log 36 base 6 is 2 plus log 6 base 6 is 1. So 2 plus 1, we're going to have 3. And this is method 1. Let's try another method and see how to solve this simultaneous equation. Now let's try the other method. That is method 2. When you come to method 2, we now to say log x base 6 equals to a. Then log y base 6 equals to a. In second method, we now take log x base 6 equals to a and log y base 6, let's say, equals to b. So we now put it in place. That is log x base 6, we have a plus, then here we have log y base 6, which is b, a plus b, then equals to 1. Then here we have a plus, here is minus a minus b equals to 1. Then the second one is a plus b equals to 3. This is equation 1. This is equation 2. So now in this case, a and a, they have the same coefficient. So we can eliminate a. So here we have remainder of minus b equals to 1 and plus b equals to 3. Equation 1, this is equation 2. So we now say still equation 2 minus equation 1. b minus b is going to be 2b. Then 3 minus 1 is going to be, 3 minus 1 is going to be what? It's going to be 2. So now here we can say 2 divide both sides by 2. This is 2, this is 2. This go with this. Then b alone is equals to 1. We have the value of b is 1. So we can now say substitute b in any equation. Substitute b in any equation, either equation 1 or equation 2, any one. We can take equation 1. That is a minus b equals to 1. Then our b is 1. So here we can say a minus 1 is equals to 1. So here we now to take a alone is equals to 1. When we take minus 1 to this one, it's going to be plus 1. So a alone is equals to 2. So the value of b here is 1 and the value of a here is 2. So we now to take it from the beginning. As here we said log x the 6 we say is equals to a. What is our a? Is 2. So here we write 2. So x alone is going to be 6 to the power of what? 6 to the power of 2, whereby x is equals to 36. And when we take the other one that we said log y base 6 is equals to v. So what is our v? Is 1. So here we say is 1. So y alone is going to be 6 to the power of 1. Y is equals to 6. So these two methods, we now solve all these two problems. That is, the value of x is 36 and the value of y is 6. Any one that you take and any one that's simple to you, you can use it and now solve your problem.